In this work, we are going to represent applications of dimension reduction techniques and data visualization. To begin with the methodology, we first mention the structure of high-dimensional temporal datasets. The dataset has many individual data entries. Each individual has multiple variables. Every variable of any individual is a time series over a time period. Each individual at a time point is distinguished by its own variable's values. An intuitive display for an individual at a particular time point is the radar chart that shows all of its variables. We can also display it as a point in a high-dimensional space. The point's coordinates are the values of its variables. Then the position between points gives us the similarity between individuals at different time points. We can reconstruct these similarities using dimension reduction techniques. We implement the approach on a web-based prototype. This is our prototype's main view with the control panel on the left and the projection on the right. The control panel has many functions, such as changing datasets, choosing a dimension reduction method to visualize the data, or clustering the data by k-means and leader bin algorithms. The clustering helps us to reduce computations for the dimension reduction process. It also groups data into several groups of different colors for enhancing the visualization. If we close the control table, another small control table will appear on the right of the projection. It provides us specific options for the current dimension reduction method. In PCA, we can switch between showing all data or just individuals at the time points when they change their groups. The PCA projection has a dense region on the right and a sparse region on the left. This pattern indicates some points are very dissimilar to the others. The prototype also provides a 3D projection and 3D projection respect time. The latter uses the third axis as a time axis to display the evolution of 2D projection at each time point. Using this option, we can see that most sparse points, the pink and light blue ones, are data at the end of the time interval. We are running the U.S. employment rate from January 2000 to May 2020. This dataset is the monthly net change in the number of employees in different economic sectors of every state in the U.S. The end of the time interval is the period when COVID-19 affects the U.S. strongly. Moving to a map, we can choose the contribution of time into the high-dimensional space. If we choose 1.0, time contributes equally to a point's position as all of its variables. In the 3D respect time option, we can also see the small group that implies COVID-19. Another outlier point is Louisiana in August 2005. We can also observe the time series of this point by opening the above panel. The vertical, dash, and black line indicates the time point of a chosen point. Louisiana underwent a terrible hurricane, namely Katrina, in this period. It is noticeable that this dataset seems to have a circular pattern because data points tend to rotate around the time axis as it evolutes. Regarding TSNE, it takes too much time for running this dataset of 6,466 data points. The quality of visualization is also not good compared to UMAP because we gain no interesting pattern or irregular points as in the previous method.
Thank you for your attention.